my name's Andrew Brown. Welcome to Real-Time Music and Sound with Pure Data. In this video we're going to be looking at probability using linear randomness. Probably the simplest form of probability in most programming languages is just the random function. And in PD it's all much the same. A random 100 object will give us values between 0 and 100. If we change that value to 10, it'll give us values between 0 and 10, and so forth. We can put a number box on the outlet to see the value which is generated, and we can bang the random to generate the random number. So we get 47, we bang again, we get 42, 83, 22, etc. So you can see we're just jumping all over the place between 0 and 100. And this is called linear randomness because the values between 0 and 100 each have an even chance. Just like rolling a dice, as though a dice had 100 sides, and we can roll it, any side could come up. And if we look at the distribution of those on a graph, we would see that they would all plot out about the same over time. So we're going to apply randomness to a couple of aspects of our audio, both pitch and loudness and amplitude. We'll start with amplitude because that's possibly the most interesting. So in order to have something to play, we'll just use a simple sine wave oscillator, and we're going to add a volume control to that. We're going to control the volume, or the envelope, amplitude envelope, over time. I'm going to use a V-line object to control that amplitude. So we're going to send the V-line a message. We'll go to a particular value, so we'll use a variable, $1, so that our loudness can vary. We'll give it a short attack, just 10 milliseconds. Then we'll go to 0 volume. We'll take 200 milliseconds to get there, and we'll wait for the 10 millisecond attack to finish before we start that. So if we send a value to that message box, 0.5, that value will be taken up by the $1 value, and the rest will be static. And that gives us a fairly simple sound. Alright, so our objective now is to use randomness to change the volume of this short note. So instead of having a fixed number, we'll use a random number. So I've already got random 100 there, but our volumes need to be between 0 and 1. So if I divide that random number by 100, that will put it into the right range. I can put a number box in there just to see what that value is. Pass that in. So hopefully you can hear that some of those notes are louder than others. So that's all good. If we want to automate that, of course, we can stick a metronome in front of it, so we get a regular pulse. We can turn that on. So as you can hear, we've sort of effectively humanized the kind of performance. As we know, if we're trying to play, say, a percussion instrument regularly like that, it's almost impossible to play with the same strength or velocity all the time, and so by varying it, we add sort of a humanizing element. We've probably gone a bit more extreme than you would normally want, from maximum to minimum volume, but that will be fine for our purposes. Now let's add a probability distribution for the frequency as well. So we'll use another random number. I'm going to use 24 because I'm going to use MIDI pitches, and 24 will be a 2-octave range. To offset it, I'm going to add 60, which is from middle C, so we'll get 2 octaves above middle C as our pitch range. We're going to turn that MIDI number into a frequency using the MIDI to frequency object, and then, and then connect that to this. So let's go to the oscillator rather. So if I bang this random here, just to check that this is all working fine. Oh, actually what we need to do is actually bang both of them. Okay, so we're getting a random pitch and a random velocity, or a random amplitude, and we can make the metronome play all of that. Okay, so randomness is a really useful function for generating variation in your patches. One thing which I will finish with is just to show you how I've implemented that into a drum machine. In some earlier videos in this series, we've talked about running sequences, we've talked about drum synthesis, and we've talked about creating drum machines, so you can look back at those videos. And so I've got here a patch which I call my probability drum machine, and it uses randomness to decide whether or not a particular hit on the kick, snare or hi-hats is going to happen on a particular 16th note. These arrays on the right hand side depict the probability likelihoods at each step, and this is what it sounds like. So that's the kind of variation and that randomness can provide, and probability distributions can provide in these kind of music that we can generate as sequences. So go ahead and give that a go in your own patches, and I'll see you in the next video.